Satish sir.
Sir, very good morning.
Yes, sir. Satish sir.
Sir, I'm hearing. Sir, is it audible from my side? Mr. Nagaraj?
Yes, sir, you're audible.
Yeah, fine.
Yes, sir, you're audible. Shall we start, sir?
Yeah, of course.
So I request Mrs. Asha to kindly deliver the welcome address.
Good everyone. Welcome. Good morning, everyone. Welcome back to all the participants for today's session. We are honored to have Mr. Satish Kumar Paramashivam, founder and CEO of I-18 Solutions, a seasoned data scientist with 2 decades of experience in teaching and research. He is a former professor, AI lead, and organizer of Google Developer Group Salem and TensorFlow User Group Salem. With his expertise in data science, artificial intelligence, and technology training, today's session promises to be an enriching and insightful experience to all. Thank you for being here and handing over the session to you, sir.
Thank you, Professor. So, very good morning to one and all present here. Myself, Satish Kumar Paramasivam. So, it's a great privilege to be with you all for conducting this wonderful FDP on the topic of generative AI and its impact in the climate change. So actually the agenda from my side is to start with what is the main representations which is to be considered while generating the code. That is what I would like to share my screen with you all.
So there is disturbance, sir. There is disturbance.
Kindly mute your. Okay. So recently, we heard that code red for humanity. Just I would like to start from the term code red for humanity. It's a term used to describe the report on climate change recently revealed by IPCC. IPCC is a panel on climate change. We should honor the report. The report states that the climate change is happening quickly across the globe and which is intensifying. This IPCC report highlights that human activity has warmed the climate at an unprecedented rate in last 2000 years. So if we look the global climate, the global temperature starts from 1970 to now. It gradually increased and it will be in the state of 1 degree centigrade. So the report which was shown over here, which specifically shows there is a huge leading edge over the global temperature. So this is human cost. The report states that the greenhouse gas emissions from the fossil fuels and deforestations are pulling billions of people at risk. As you people are well aware about how the global temperature are increased considerably. Right now, everyone is talking about the climate change. But as a computing, as a artificial intelligence profession, we should be aware of how we are going to reduce the carbon footprints, which is to be as a part of our repository. That's the thing. As an AI engineer, I have to be looking for how I am going to reduce the carbon footprints. That is the thing which is to be our part. Currently, this is the trend shows that the carbon CO2 emission per year is increased like this. So US at top 400 billion tons, followed by European Union and China. Subsequently, we are in the current stage, followed by the United Kingdom. So these are all the current data which talks about the CO2 emission, CO2 carbon dioxide emission per year is 51 billion ton. So this is very high. So you can have the information with this site geographical.co.uk climate. You can go. I will copy it. This one. Eventually, you can see a plotly graph over here in order to know what will be the emission. So, how carbon emissions impact climate? This is from geographical. So you just listen here. This is the chart I did in my presentation. So you have a clean indications that your United Kingdom is on the top right now. Eventually, European Union followed by the United States and Canada. During that period, we are not entitled ourselves in the chart, but later in 19th century, we are available over in the chart. The pathetical situation is India is 920 lbs per year. That is quickly we are growing towards the first stage. This is the cumulative CO2 emissions over in the past history of the world. So how these emissions are calculated by means of the carbon dioxide. Okay, so emissions from all other greenhouse gases. So that equivalent value will be calculated over the CO2. That is the fact. Emissions from other gases are converted in terms of carbon and the measurement. Okay, with respect to the carbon, usually termed as CO2. Not only with the CO2. So we can have the emissions from the methane, nitrous oxide, and chlorophyll and water vapor also. So this carbon footprints are calculated and represented over here. So how I am going to compare myself along with the normal contributions of CO2e? At last, you can see that 56 times, once if you train your neural network from the scratch, it will be equivalent to the 56 times, 56 times of the human life. Just think about it. A lifetime air travel from New York City to San Francisco by one passenger is 2.0. Training an AI model is 626.2. That is the emissions. That is the emission which is caused by training the neural network model from the scratch. So it's huge. So we have the responsibilities of how we are going to reduce the CO2 emission in order to maintain the sustainability. That's the green computing. That is the fact we are going to look by today session. The lifetime, American lifetime is 36.2 LLBS. And US car manufacturing and fossil fuel consumption is 126, the emission is. But training an AI model is higher. That's what we are in the pathetic situations. So you can have a paper called technologyreview.com by 2019. Training a single AI model can emit as much as carbon on as 5 cars in their lifetime. So you can go and check with the article in order to know how the carbon footprints are emitted. Training a single AI model can emit as much as carbon as 5 cars in their lifetime. Deep learning has a terrible carbon footprints. So a couple of years or recently 1 year back, just we thought that we are going to do our research work based on the neural network architecture. But now the neural network architectures are the core computations of the AI. So once if you have the data, recently I got one article that he told that the computations are growing fast. But the data, the question about the data, the creations of the data is very less. The fossil fuel for the AI is the data. Data is treated equal to the oil. So you can by means of the oil you can have some different types of verticals, no? Like that. Once if you have the data, we have different types of verticals on the AI. So the fossil fuel for the AI is data. But we are in the pathetic situation of if you train your data from the scratch, it will cost as much as long. So that is very important thing. Here I have one information. Once if you train the data with the transformer of 65 million parameters, I will explain what is this parameters and other technical details later in my slides. I will explain what is transformer also in a clear representation from my slides here. So the energy consumption is 27 kilowatt. So the carbon footprints in the LBS of CO2 emission is 26. Suppose if you work under the cloud computations, the cloud computation cost is about $41 to $140. So that too you are working with the 65 million parameters. Just compare that. Currently the GPT-2 takes, the computation cost is around $12,900 to $43,000 US dollar. It's a huge nightmare of the people, those who are working in the artificial intelligence. This is the area you have to be concentrate on how we are going to utilize the cloud computations as well as the libraries and the techniques and tools and some programming aspects. That's very, very important thing have to be noted over here. So the transformer, yesterday also we hear that the transformer and professor he clearly explained about the architecture of the transformer. Those who are I think those who are having interest over the transformer, you might just recap the yesterday's session. Yesterday I attended the yesterday's session also. So professor cleanly explained the architecture of the transformer, and he explained what is encoder and decoder subsequently, how it impacts over the normal neural networks. See, for theoretical representation of ANN, artificial neural network, he informs us, as you people are well aware about that, it's the mimic of the human brain. ANN is the mimic of the human brain, right? So human brain, the think and thought of the human brain will be a mimic of the artificial neural network. So, as a computation professional, we should clearly understand how we are going to convert our thinking into mathematical. That is the thing we have to be curious about it. Whatever the thing, if you have anything that to be converted as mathematics, that is what on the another side of AI, that is artificial neural network. See, for example, if I have a thought of purchase a shirt, immediately my mind tune what will be the color of shirt, and what will be the fabric of the shirt, and what will be the style of the shirt. So here, just it will be extended to the think. Normally, human minds thinking is maximized to 60,000 thoughts. Right now, I am restricting the thought of purchasing the shirt is with 3. One is the color, and another one is the style or the structure, and another one is the fabric. Okay. So I thought that just I would like to take yellow color shirt with off sleeve with the cotton fabric. A simple illustration about how the ANN mimic our think. So this is my thought. Just I would like to purchase yellow shirt with off sleeve with cotton fabric. In my mind, I assume some colors, yellow color with some weights and fabric with some weights. Let me take one whiteboard. So this is the color, and this one is the structure design. Hope you have my screen on. Is my screen
Yes, sir.
visible? Yeah, fine.
Yes, sir.
Yeah, fine. And we have some other structures. So this is my fabric. So I treat this as x1 for x1 with this as xn. This as xn. Now, what I am thinking is, just I entered into the shop. I'm looking for the shirts with the yellow color. The salesperson has shown some shirts with the yellow color, but what I am thinking that my color, which is in my mind, is not matched with the color what he showed. So simultaneously, I would like to confirm that okay, it's okay. I'm okay with that color. So the weightage has to be given as 7. But I thought that a color in my mind with the weightage of 10. But unfortunately, I can satisfy myself with the 7. But there is no off sleeve shirt. It is full sleeve. It is 0. At the same time, we have a fabric which is semi-cotton. That too also, it is not to my level. Just I would like to reduce my weight as 8. So this is x1 and this one is x2, right? This is xn. Now, as you are aware that the computation starts with the hidden layer that is equivalent to the summation of I equivalent to 1 to n xi wi. Xi wi. So this is 1 with 7 is 7 plus 0 plus 8, that is 15. So you can have the formula like this, no? I equivalent to 1 to 0. I equivalent to 0 to n xi wi. Xi. Sorry for my handwriting. Xi wi. So this is now 15. This is now 15. which is able to predict the value output, whether I am going to purchase the shirt or not. How I am going to predict that, whether I'm going to, how the machine is going to predict whether he is going to purchase this or not. So just this will be compared with the threshold value. My threshold value is 12, which exceeds the value, my the output is 15, so it exceeds. So this is the process of predicting the output. So my thought will be converted as ANN. That's what the neural network talks. Hope you understand this illustration. But if you consider the inputs are very long, so my ANN is a core. Now it will be entitled to the transformer. I think in the year of 2019 or 18, we have attention. I will share that screen also. Attention is all you need. Dear professor, hope you have my screen on. My screen is visible.
Yes, sir.
Yeah, fine. Attention is all you need. So this is the paper which is published in the year of 2018. Starts in the year of 2018 by the Google DeepMind. So this is the basic paper which talks about the transformer. Yesterday you got that architecture, no? So that architecture will be reflected from this paper. So kindly note this paper. So this is very important paper. It talks about the architecture of the transformer. Yesterday we got the professor has explained about the embeddings and other networks actions, multi-head attentions and other things. No? So this will be come from this paper. Kindly have this paper with you all, those who are interested in artificial intelligence. So this is the birthplace. So from every model has starts from here. Every models are start from here. This is the architecture of the transformer. So if you want, I will share these papers to you all in the comment section. Is my voice is clear, or professor, is my voice is clear? Why somebody text me voice is not clear?
Sir, it's clear, sir.
Yeah, fine. So this is the paper by the DeepMind, Google DeepMind. It talks about the architecture, complete architecture. Once, if you want to get into this, you can have the clear idea of how the content will be transformed and what will be the functions and how the key as well as the vectors are transformed to listen, and how the contents are transformed from one representation to another representation. Everything will be clearly explained in this paper. So this is the root paper. So I have some source code for explaining this paper in a live manner. So that's what we are into the phase of the transformer. If you consider any inputs to the machine learning or deep learning model, it will be a simple numerical representation. It will be a simple numerical representation. That's all. It's a very simple numerical representation. It's a simple numerical representation. That's what the transformer came. For an illustration, just I would like to show you one more structure, code structure. So sorry for the quick transition from the window to some other prompts. Kindly ensure my command prompt is visible or not.
It's visible, sir.
Yeah, fine. See, for example, whatever it may be, if from PIL, for example, just I would like to have an image. So let me take any image. Let me take one image. Image as elephant. Download. So let me take one real example of elephant.jpg. Okay. So now the elephant image, no, what I am showed here, it's not shown with you. No? So this elephant image, I downloaded this elephant image. Okay. So that image will be converted as an object. Now, what I'm going to do is, now you are seeing the image will be converted as a three-dimensional array. That image will be converted, completely converted as a three-dimensional array. Here, so this is what the input to any model. This is what the input to the any model. But earlier we have the extension as JPG or BMP or blah blah blah. It will be for the clarity of the persons those who are using. But as an ML engineer and AI developer, you have to be cautious about everything will be converted into vectors and scalars. So this is the array. So here x equivalent to x dot n dimension. It will talk x dot n dimension. It will inform that it's 3-dimension. If you call x dot shape, it shows the pixel size 183 into 275. This is the pixel size with the 3-dimension value. So x dot size, this informs that it is the size of the array. This is the shape and this one is the size. So this will explain about how much of bytes it will occupy. It occupies 1 byte. So this will be talk about total number of memory it will occupy. This will be the total number of memory it will occupy. So everything will be converted into matrix. That is the fact we have to be ensure ourselves. So how this will be related? How this will be related is nothing but the quantization. If it is a very big block, If it is a very big data with millions and millions of matrix, the huge matrices represent, so that will be a very crucial stage for that AI developer to install the particular model into your commodity machine, the local machine. Your local machine does not have the capability to hold the entire module. Even though if it does not have the capability to hold the entire module, just think about how the calculations are performed over the model. That is another problem which is to be considered as more crucial part of the model inference. So as a AI developer, we have to be cautious about the data, the value which is to be stored in your array. That creates a very big impact over the model quantization. Once if you quantize your model, then it will be convenient for the computational cost also, as well as the computational speed. As you people are well aware about, if you are in the position of dynamically creating the memory during the calling of the particular method, then destroying the memory is more beautiful part of the programming, no? The same aspects here will be represented in the term of quantization. One more simple illustration. This example shows how the model, how each and every input will be considered as a vector. So the second illustration, what I'm going to show is my command prompt is visible? Dear professor, kindly ensure. Hello.
It's visible.
Yeah, fine. So next one is suppose, say for example, if I'm creating a simple array with 10 size equivalent to 3 by 3. Size equivalent to 3 by 3. So within 10 to 20, just I would like to create an array of 3 by 3 matrix. 3 by 3 matrix. So this is 3 by 3 matrix. So I'm asking what will be the size of the matrix. So here it will inform that it's int 64. The value 17 occupies 64 bits of memory. That is the thing which here it's revealed. So I'm asking what will be the total number of bytes allocated by this simple matrix. So this matrix, this 3 by 3 9 element matrix occupies 72 bytes, because each and every item size is 8 bit. 8 into 9, it's 72 bytes. 8 bit. So 8 byte, this is 8 byte, I mean 64 bits. So I came to clear my mind that whether 64 bits are mandatory to hold the value 17. The 17 is the value. 17, assume that 17, if you ask the bit length will be within 4 or 5. It's 5 bits, it's enough. But what about the rest of the bits? So it's unnecessary to make the storage, no? So my question is, by default, once if you incorporate any matrix, the size will be in 64 bit. But this particular value require only 5 bit. So the remaining bits are entirely waste. So you have an option of quantized from here itself. Now the same value with memory will be reduced. Now the same value the memory will be reduced to 9 bytes rather than 72 bytes. Rather than the 72 bytes. It's look more beautiful, no? So the quantization, once if you have a good knowledge about how we are going to work with the objects and how we are going to work with the data types, that's more fine. So this is the case which will be considered in the neural network architecture. But whereas in the case of transformer, the input which we are facing is millions and millions of inputs. So we people have to be cautious of what will be the resources which I am going to make use of making the training of the model with the support of not leaving a very big carbon footprints. That is the part which we have to be considered in order to make ourselves to be contributor for the less carbon emission. That's what my talk is here. And then one more important point to be considered is the requirements, the hardware requirements. Right now I am shifting to the PPT. So I classify myself with the three category. One is the initial step, and another one is the mid step, and another one is the higher end. So here I am mentioning some products. I will share one PDF with you all. So this PDF talks about the hardware requirements. Actually I prepared this for my requirement, AI requirement. So this is entry level. So if you choose AMD processor, that is Ryzen with the 7600X desktop processor with the 5.3 gigahertz speed. The motherboard is this one. The main part is the graphics card. So just I am suggesting 3D RTX 3050. It will be cost around 26, 27 or 28,000. So this is the entry level, and this if it is Intel processor, just I opt for i5 with 13th generation with the RAM of 16 GB. So at the initial stage, at least we need 16 GB of RAM. With the graphics card of RTX 3050, the same. If it is mid-level, my suggestion is 7700 desktop processor with the graphics card RTX 4060. The RAM is 32 GB, DDR5. If it is in the case of Intel, if you are going for Intel, just I suggest to make use of i7 desktop processor with the gigabyte RTX of 4060. But if it is in the case of higher end level, with the Intel processor is latest Core i9 with the 14th generation, 13th or 14th generation with the 4080 graphics card. graphics card. Almost it price around 1.5 lakhs. It's priced around 1.5 lakhs. Once if you set up the machine, just right now we are preparing a machine with the 4060, that will be cost around 2.5 lakhs. The power consumption as well as the emission is very higher in this range. In this range, the emissions are very higher. Choosing the graphics card is very, very important. The performance, the leverage of the performance is very important while training and inferencing. If it is 4050 or 4030, it takes time, it takes a day. The completion day with the epoch is highly appreciable with the higher end graphics card. But as we people are understand that graphics card is earlier used for the graphical purpose for playing video games and other things. But how we are going to make the graphics card to be used for performing the high level scientific computing? That is a very important thing we have to be considered. For that, NVIDIA came with one important framework, programming framework, that is called as CUDA. That is called as CUDA. I will back to my presentation. NVIDIA plays a key role in artificial intelligence, inventing the GPU in 2009 or 8, and that region, and that time he invented the GPU, graphical processing unit, creating NVIDIA CUDA program. CUDA is nothing but Compute Unified Device Architecture. It's a parallel programming model which was computed in the C++ language, that leverage the use of the GPU card for non-graphical purpose. Non-graphical purpose is high-level scientific applications. So earlier if we have the machines with the graphics card, we are using for the pixelate. Say for example, if you are watching with any movie with 1080 pixel, the FPS frame per second is 60 FPS. So it will dips it to 2 millions of pixels. So the graphics card is essential for making the pixels to be gathered and the performance, enhance the performance of the watching. At the same time, why don't we have the same graphics for parallel computation? That's what the CUDA is in process. That's what the importance of the CUDA plays a role. CUDA is nothing but Compute Unified Device Architecture, a parallel computing platform that leverage or that allow you to use your GPU for more than just playing the game, which was developed in the year of 2007 based on the prior work of Ian Buck and John Nicholas. We have one paper that is called as Brook for GPU. That paper allowed the NVIDIA to create the GPU with CUDA. Since CUDA has revolutionized the world by allowing the human to compute large block of data in parallel, which unlock the potential of deep neural network, which is behind the artificial intelligence. That is the fact. This CUDA revolutionized the world by allowing the human to make use of the large block of data in parallel with your systems. This GPU is historically used for computer graphics, as you people are well aware about the graphics card. As I already stated that if you play a game with 1080 pixel at 60 frame per second, you have got over 2 million pixels on the screen that may be need to recalculate after each and every frame, which require a massive hardware that can do a lot of matrix multiplications and vector transformations in parallel, no? So that we have an enhanced vision of the particular game. But modern GPUs are measured in teraflops, trillions of floating point operations per second. Unlike the modern CPU, say for example, if you consider the current recent Intel Core i9 with the 13th generation, which has only 24 core, but a modern GPU like RTX 4090 has over 16,384 core. So these GPUs are designed to go really fast in parallel with CUDA, which allow developer to tap into the GPU power and make the data scientists are using this moment trying to train the most powerful machine learning model. That's what the CUDA plays a role. So the CUDA kernel, it's a simple function that runs on the GPU. So the architecture is very simple. Say for example, it looked like IO processor. As you are well aware about the IO processor, so if the request comes to the IO processor, the actual processor relinquish its control based on the request, as we are well aware with the computer architecture. It relinquishes its control by the command. Again, after the let the IO processor to leverage the process. During the time the CPU is in idle. Like that, here the processor, if there is any request from the CUDA, the CUDA kernel will be working in the GPU itself. It copy the data from your main memory RAM into the VRAM of the GPU. VRAM is nothing but video RAM. VRAM of the GPU. Then it will inform the CPU that the function will be executed in parallel. So I have a beautiful session on how these architectures are working and how the CUDA functions are parallelly working with the other NumPy or Torch. So that will be discussed later. But as a AI developer, AI engineers, you have to be cautious of these kinds of computing environment in order to make the work to be more stipulated and leaving less carbon footprints. So one more important thing is that how I am going to select the model. Prior to the selection of the model, every AI engineer has to be cautious about this ML/CO2 calculations. So one more time, we have some different papers. I shared after the completion of the session. I will share this content to the chat box so that you can refer the papers for your work. So here, ML/CO2 calculator. So which calculates the CO2e, carbon emission, depends upon the hardware as well as the cloud preference you selected. So based on the carbon emission, the engineers has to be convince ourselves in order to select the training model and deploy the model with the data and perform the inference. So you can directly check with this. ML calculator. Open with the Chrome. ML/CO2 calculator. So this is the GitHub page. So don't directly go to the GitHub page. So use impact. So this is the URL. I will share this URL right now to your chat box. So here, compute your GPU carbon emission. Push for more transparency in our field by including the results in your publications. Install Code Carbon. Code Carbon is another thing. So this is machine learning emission calculator. So you are here to select your computing environment, the hardware. That's what initially I stated, that the hardwares are growing too fast. The computation facility, the cloud environments are keep on increasing, but we are facing the problem with the data. So let's take RTX 4090, that is the hardware type GPU. So I'm going to make use for 100 hours with the Amazon Azure. Let me take Google Cloud because I'm a Googler. Google Cloud platform with the Asia's East. Right now, I am computing how much of CO2 it emit. So once if you have the GPU of 4090, it will emit 16.8 kilogram of CO2. $16.8. Suppose if you change RTX A6000 with the same, yeah, of course, it's equivalent, 16.8. So this is Tesla T4. Let me check with the same. This emit only less. So selection of the hardware is very important. It based on what type of data you are going to deploy and what type of model you are going to inference. Based on that, you can check this green revolution also. So like one important interesting fact is that I'm going to select RTX 3090 for I'm going to work for 100 hours. That is 19.6 kg of CO2. So which gives the equivalent of 79.2 kilometers driven by an average ICE car. So with the carbon emission, which is equivalent to 9.8 kg of coal burn. So with this calculator, you can check what kind of impacts or what kind of content you are going to make the green computations. That's the carbon footprints. How much of carbon footprints you are going to leave. So the environmental fact is also very important because we are in the terrible state. நமக்கு ஏற்கனவே தெரியும் எவ்வளோ ஃப்ளக்ஸ் வருது எல்லா இடத்துலையுமே. நேற்று கூட பார்த்தீங்கன்னா கிட்டத்தட்ட எவ்வளோ மில்லியன் பனிப்பாறை வந்துட்டு ஆர்டிக்ல ஃப்ளோ ஆயிட்டு இருக்கு அப்படின்னு சொல்லிட்டு. ஸோ குளோபல் கிளைமேட் சேஞ்ச் அப்படின்றது நிறைய பேசக்கூடிய ஒரு விஷயம். So as a AA engineer, we have the responsibilities of reducing the content. So the calculation is taken by kilowatt of electricity which is used into number of hours and the model and then the computations. That's very important. I will share the formula to you also. Hope you understand the thing, what we thought about the carbon emission. Sorry for not leaving you for some free time. If there is any queries from your side, kindly raise. I am ready to answer it. Dear professor, if you have any queries, kindly raise your shoot. Any queries from your side? You can use the chat box to query me.
Sir, what are the recent advancements in transformers?
So,
What are the recent advancements in transformer models?
I will explain the transformer to you
Okay, sir.
shortly so that you will have the correct clear answer for the query.
Okay, okay, sir.
So, in order to leave a minimal footprints, the AI community suggests using pre-trained modules. Try to make use of pre-trained modules whenever they are available. So almost right now we are in the pollution of LLM. It's LLM pollution. So this is, instead of fine tuning, try to make use of the RAG as well as the agentic flow. Starting with smaller experience and debug, how much of computation it will require. And one more important thing is doing a literature review to choose the hyperparameter range. So these are all the suggestions from the developer communities in order to make a sustainability, in order to maintain the sustainability. One more important thing is use the local AI. Use the local AI. Using the local AI is so beautiful. It will be associated with Olama. So I have one real practical examples for how I am going to make use of the local AI shortly. So for transformers, one important thing I have to show to you. So it's my collab. So this is AI18N page. I will share this collabs to my GitHub page so that everyone can access it. So I would like to open one notebook which talks about attention. Yeah. So earlier I talked about attention, all your need is, all is your need. So I implement the paper with the practical knowledge. Here RNN, so a recurrent neural network model is used to be state of art for sequence and sequence to sequence modeling. Sequence can be ordered a set of token which would like to be words. அதோட disadvantage என்ன அப்படின்னு பார்த்தீங்கன்னா, we need to feed the inputs one at a time in order to generate the output sequentially one at a time. Although training the algorithm is pretty slow, the vectors are generated intermediately for every word in the case of language model. So that I am looking for the transformer. So if you have the chance, kindly open the paper which was already sent by me. Attention is all you need. So he mentioned the vector, what I am looking for. Q is the query, that is what I am looking for. K is the key, what I can offer. V is the value, what I actually offer. So I have three part. One is QKB. We have a query vector, key vector and value vector. That is randomly initialized, is going to be the length of the input. Here I am randomly initialized three vectors. This is Q vector. This is with the shape of 4/8. This is key vector, and this one is the value vector. This is the transformer. Live example for the transformer, which was stated in the paper. Attention is all you need. So let's talk about the self attention. In order to create the initial attention matrix, so here this is the function. You can see the same diagram represented in that paper also. So in order to create the initial attention matrix, we need every word to look at every single other word just to see if it has a higher affinity towards it or not. Say for example, my name is Satish. So that will be the content which I am going to transfer into the transformer. So I am applying the softmax function over these three matrix. So this is Q matrix. So the transpose of the K matrix divided by the square root of dk, that to be multiplied with the V matrix. Right now I got the Z matrix. So this is the fact which will be implemented here. So here the variance is, you just listen here, the variance is very little bit, 0.7, and but here is 4.14. So these are all limited with 0 to 1, but this is very high. So I would like to scale, I would like to perform the normalization. Yesterday, professor told the self-attention layer and normalization. This is the practical case what we looking for in the normalization. Just I am scale the particular value. The scaled value is 0.5. Now 0.5, which is within the range of 0 to 1. So this is the scaled value. Now you can see the scaled value is 0.5 instead of 4.14 here. The value for the matrix is 0.5. So this is the transformation, clear transformation. One more important thing, now we are going to talk about masking, which is widely used in the decoder part. Encoder part is over, but this is the decoder part. So I am using np.trill for having the diagonal matrix one. This is the triangular matrix. Now I want to transform every 0 as infinity. So this 0 to be transformed in the encoder phase with the infinity. So mask np.infinity will be applied over here. Now it will be transformed as infinity with 0. So this is the scaled matrix. Now what I'm going to do is just I would like to make use of this encoder representation as well as representation in the softmax operation. So this is the x value will be raised to the exponent, and in the denominator stage we have the summation of j. So which will be calculated with the function called softmax, and this is called the attention. And then the final attention is came over here. So still it's working. I'm checking with the value. So there is no, initially it will be with the value and the new value will be here. This is the first value. So after the transformation also we have the same representation. Listen. So this is the computation of self-attention. This one will be the earlier, which is exactly the same. My name is Satish. So this is the action of, this is the practical code which will be computed for the illustrating the how the transformer is working. It's very simple. Once if you have the mathematical intuition about the transformer and its work, you just try to refer this attention.ipynb. I will share it. I already shared it in my GitHub. I will share my GitHub link as well as the article to you all. One more interesting fact is, earlier I talked about the local AI. So let me have one. I will share one local AI platform. So that too interesting. If you have any idea, you just try to use this model, Olam. Hope my screen is visible.
Yes, sir. Yes, sir.
Yeah. So this is Olama. Olama. You can refer the site olama.com. Get up and running with large language model. So it supports Llama 3.3. That is the recent one, and P3 and Mistral. Even the Google Gemma 2 also. Gemini and Gemma models. You can download the version for Olama is Windows. You can have the Olama to your Windows machine as well as Linux as well as Mac machine. So this is the local AI. So I prefer to make use of Olama for model inferencing. That's so good. That's so good. Let me explain this Olama with the practical approach. So, I would like to share my command prompt. One simple example is my command prompt is visible for everyone. Is my command prompt is visible? So, dear
Yes,
professor, is my
sir,
command
yes, sir,
prompt?
it's visible. Yeah. It's visible, sir.
So right now I am working with Olama. I already installed this model in my machine. So I'm using Mac OS. So here, for appropriate environment, you just try to download it. So the site will automatically wizards you to the proper downloads with the model Olama. So here, this is the model Olama, which was already downloaded by me. So it's available here. It's available here. So main important thing is the local AI. The merits of local AI is by manipulating data locally on machine. This model considerably minimize the need to transfer sensitive information over the internet. Say for example, if you have your local database or local content, if you don't want the particular content to be revealed over the internet, you can make use of this local AI. That is the main important important fact of the local AI and Olama. Another aspect is with the minimal dependency. I don't have any budget for recruiting or extracting the GPU from the cloud. During the time, just my requirement is very minimal, but I would like to run the Llama 2 or Llama 3 or Gemini or Gemma models. So I can immediately make use of Llama without any operating environments. In fact, the key shared keys and APIs are not necessary for deploying and inferencing this model. That is the main merit of this local AI. Okay. Olama is nothing but omni-layer learning language acquisition model. Actually, Olama is omni-layer learning language acquisition model. So you can go and refer the site. The available models are with the Llama 3.2, 3.1, Gemma 2, Mistral, and Starlings, Code Llama. Everything is available over here. Okay. So you can easily work out this model. So suppose if you want to run this model, I'm going to give a simple command Olama run Llama 2. So I already deploy the model Llama 2 in my machine. So during the initial stage, it will take some time. Once the model is deployed, depends upon the computation of your machine. Once the model is deployed, it's ready to responsive. Right now, you can see the model is starts its talking. Meanwhile, I would like to show one more important fact. You have to create one file. That file is called as model file. That model file might consist of a simple prompt which you are expecting. So now the Olama is ready. So I'm asking, tell me about ATAL FDP in 100 words. It will try to extract the data from everywhere, no? So probably let's check what will be the inference given by the model. So this is what we are in the need of the high processing computation GPU. But in fact, this machine does not have the capability. Right now, it's ready for responding with us. So the inference has started from. ATAL FDP is a flagship training program of the ATAL innovations. Oh my God. A government initiative under the Ministry of Education, India. My screen is visible?
Yes, sir.
Yes, sir.
Yeah. How this Llama 2 got this information? That's the fine, no? That's the fine. Just I restrict my blog to be within 100 words. So this is my prompt. Tell me about ATAL FTB in 100 words. This is my prompt. It will respond in a clear manner. Hope you have clear idea. It depends upon the prompt. It depends upon the prompt. It will respond to you. That's the fine thing which we have to be working with this local AI model. So I think 100 words is too big. Initially, I have to set up with the 50 words. Okay, so that's good. So if you have any content, say for example, if your prompt, so if I'm typing exit, it will inform what is exit. So actually, this is the inference state. Still, I'm not get out of the Llama 2 model. Sorry, I don't know. I'm running out of time. Llama. I close this and I will show one more content to you shortly. So it takes some time. So how I'm going to prompt this? One more simple example for the prompt of Llama. So here is my VS Code. I'm going to make my VS Code is visible. Dear Professor, kindly conveys my content. Hello.
Yes, sir, visible.
Yeah. So so this is a simple VS Code. Just I already created one folder. So this is the prompt. Prompt is: you are a climate vati created by Satish Shivam. You are responsible for answering the questions related to the climate change, CO2 emission, deep learning, and generative AI. This is what my prompt. So actually, you have to import the Llama 2, and you have to give the parameter. Just I define the parameter value as 1 for accurate information. Suppose if you want any staging or any creative information, you can increase the temperature size to anything with the limit, the 2. Okay. So kindly check what will be the temperature value for the generative AI. So here I mentioned as 1. So this is my model file. I created a model file in the directory. So I already created another file called model file in the name of AI Vati. AI Vati அப்படின்னு நான் create பண்ணிருக்கேன். This is related to the machine learning and deep learning and generative AI. Both the model files are created by me, and it's available over here inside the folder called Llama_template, which is available in my local machine. So I'm using VS Code over here. You can use any editor. So right now, again, I'm back to the command prompt. So CLI. Now what I'm going to do is just I would like to call my CLI. So again, I'm back to CD, my folder, no? Is my command prompt is available? users, Session1, and development. Within the development, I have the template called LangChain. Is my screen is available?
Yes, sir, available.
So I have in my development, I have LangChain, ML datasets, Tableau. Olama template is available. Olama template. So right now I am inside the Olama template. Now I am going to call the Olama create that climate Vati, no? Climate Vati with my model file. You can have your own name. There is no restriction. It does not relate to the prompt which I already shared with you. What happens to this? I think Olama is not running. Initially run the Olama. CD users. It's not running. Now it's running, no? Create. So that's what you have to run the model. Create climate Vati and AI with the file, not my model file. My model file, which consists of my content. So it's informed that it's success. Now you can run climate Vati. Olama run climate Vati. It's not. Let me check with AI Vati. Yeah, AI Vati is running. So this is the prompt. My Llama 2 is response with my prompt. So your AI Vati is right now ready. So I'm asking, what is the formula for softmax function? I'm simply asking, what is the formula for softmax function? I already informed that my model file will be treated with the prompt that is responsible for answering the questions asked related to mathematics, deep learning, climate change, or generative AI, or anything. So that prompt was already informed through Llama 2 to the Olama. Now your Olama is responding with the model inference. You can check it out. softmax of x equivalent to exponent of x divided by summation of exponent of x, I think. That is the formula for softmax. Exponent of, yes, perfect, divided by summation of I equivalent to 0 to n exponent of x. Perfect. Where x is the input vector to the function, exponent function is element wise exponentiation. It's clearly informed. So what I'm going to suggest is, so whenever there is a requirement of the minimal inference with the models, kindly deploy this. Even we have a lot of models and works. Hope you understand. Sorry for not waiting the Olama to response for a long time. Just I would like to close this and let me back to the next content. Okay. So this is what the fact locally. So here the conversion points are the thing. Conversion points are very important. One more important aspects along with the LLM is, as Professor clearly informed that GPT is LLM, OpenAI is not an LLM. OpenAI is an API. Okay, OpenAI is an API. GPT 3.5 and GPT 4 are Gemma, Gemini. These are all the LLMs. So it does not respond to your local database. That is the fact you people have to be good with. It does not respond to the local database. Local content cannot be entitled. It cannot be the LLM cannot be seen in your local database. How far you are going to make this bridge? How you are going to tie your local data repository to the LLM is through the AI framework called LangChain. So that is some separate corridor that will treat your AI work to be more smooth. Once if you have the familiar with the LangChain and its classes and its method, it's very beautiful to see how the AI and all these models are responding with this. So for an example, just I have my another content. I would like to show that content to you all. So LoRa is separate one for the quantization. I have some examples also. So this is the prompt, and let me check with this Hugging Face or my recent research work with NLLB. This is another example. Sorry for very fast. So here I am using the transformer. Hope my file is on your screen. Kindly confirm.
Yes, sir.
Yeah, this is the transformer. I already installed the transformer. I'm using auto tokenizer as well as auto model for sequence to sequence LLM. So this is the fact which I already showed you in my matrix attention.py Python. So here what I'm going to do is just I would like to make use of Facebook NLB. So NLB is a separate model which is called as no language left behind. So I work with the internationalization. That's what my company is coined as IA18N. So I'm working with the internationalization of the language. Almost I did for 500 plus languages. My research is going on with this. This is a very good example. So what I did is, this is the tokenizer. It's a class. So this is my model class. So which was already downloaded by myself. So here I'm working with one content. This is the document text, and I pass the text to the tokenizer. Now the tokenizer inputs will be feed to the model, and it responds that. The translated text is here. This is an example. So the clear translation. Yes, the posters suffer from the depression. Reasoning: the post exhibits strong indicator of the severe depression. The poster described feeling a sense of despair, hopelessness, and exaggerations in their interaction with the customer at their job. They express hatred towards the people and fluctuations with their actions, indicating significant emotional distress and the lack of fulfillment or satisfaction in their work. The poster also mentions self-harm, suicidal thoughts, and personal struggles outside of work. It's a very big text. So I got the conversation. You just listen here. The conversation is here. Poster மனச்சோர்வுக்கு ஆளாகிறது. அதோட ரெஸ்பான்ஸ் என்னன்னா, இந்த இடுக்கை மிகவும் கடுமையான மனச்சோர்வுக்கான வலுவான குறியீட்டை காட்டுகிறது. அழகா தமிழ்ல டிரான்ஸ்லேட் பண்ணி கொடுக்குறான். So why I am selecting this NLLB? Because if I am selecting Gemini or Gemma models, the parameters are very high. The parameters is nothing but the weights as well as the bias. Again, back to the neural network, artificial neural network, the weights as well as the bias. So adjusting the weights and bias is very important. That is called as backtracking. As you people are well aware about the architecture of the neural networks. அதெல்லாம் ஆர்கிடெக்சர் வந்து பாத்தீங்கன்னா இப்போ வந்து டிரான்ஸ்ஃபார்மருக்குள்ளார வந்துடுச்சு. அதெல்லாம் கோரா மாறிடுச்சு. இனிமேட்டு நம்ம வந்து டிப்ரிகேட்டட் தான் அது அப்படின்னு சொல்ல முடியும். டைரக்டா அதுல ரிசர்ச் எல்லாம் பண்ண முடியாது. அப்சல்யூட் ஆயிடுச்சு. சிம்பிளா தமிழ்ல சொல்லணும்னா. ஸோ இப்போ அதை நான் வந்து வேற லெவலுக்கு கொண்டு போயிட்டு இருக்கேன், மாத்திட்டு இருக்கேன். அதை வந்து டேட்டா மைன் பண்ணி கொண்டு வரலாம் அப்படின்ட்டு ஒர்க் பண்ணிட்டு இருக்கோம். ஸோ இப்போ மில்லியன்ஸ் ஆஃப் ட்ரில்லியன்ஸ் மில்லியன்ஸ்லாம் பேராமீட்டர்ஸ் இருக்கப்ப தட்ஸ் நாட் சூட்டட் ஃபார் சிம்பிள் டிரான்ஸ்லேஷன்ஸ். ஸோ தட் ஐ செலக்ட் திஸ் மாடல். ஸோ மாடல் டிரான்ஸ்ஃபார்மர் செலக்ஷன்ஸ்க்கு வந்து பார்த்தீங்கன்னா we have a lot of repositories. One important repository is Hugging Face. So this is the transformers. So we have a lot of models. Hope you have my Hugging Face screen on your view. Kindly create your account and make use of these Hugging Face models. So the models and libraries are here. You can, this is multimodality, supports multimodality. From that I selected. You just listen here Llama 2, its model. These are all the Llama 2 models. Fine-tuned model by MLA Bone. ADI 007, they fine-tune. These are all the fine-tuned models. So once if you want any data sets, it's available over here. Even my data sets are all available here. So many data sets are available. You can have the models based on your requirement. If this is for multimodality, this is for computer visions, and this one is for NLP, and this one is for audio, and this one is for tabular, and this one is for reinforcement learning. One thing, dear professors, kindly consider that fine tuning is RIP. Here the fine tune is absolute. Right now, the reinforcement oral fine tune, reinforcement fine tune, and RAG, retrieval augmented generations, are in the queue. So instead of fine tuning, we have a lot of segmentation has been available. So the AI is advanced by a day, not by a month or by 6 months. It's day by day. there is a versioning. The versioning has happened day by day. So we have to keep track of what will be the current trend. Any doubts, or I think I'm too fast with the exposure of live without any PPT and presentation. Sorry for that. That's IAM industry. That's what I came to show all the content in the CLI itself. Do you have any queries? Kindly raise me. I will show an example of how the Langchain responds within 10 minutes. Sir, Mr. Nagaraj, sir. Sir, Nagaraj, sir. Can I extend the session for another 10 minutes? Or?
Hello, sir.
Sir, can I extend the session for another 10 minutes?
Yes, sir. If you want, you can extend for 10 more minutes, sir. Hello.
Yes, sir. Yes, sir.
Yes, sir.
Is my command line is available?
Yes, sir. Yes, sir.
Fine. So here, Langchain community, we have a lot of LLMs. You just listen here, import. So many LLMs are tied with here. So these are all the LLMs. These are all the LLMs. Even you can have from transformers. Prior to that, we just try to install the transformers by using the command or conda by pip install transformer, which was already installed by me. Which was already installed by me. So from Langchain _ community. So Langchain community, it's available. Langchain is available. See, for example, if you want to load any documents, document, you can use document loaders and you can use PyPDF loader. So this will be used for PyPDF loader. This will be used for loading the document, PDF document. Okay, so you can use loader by PDF loader of this is the place where you have to give the URL of your path. Say for example, any content is loaded. Downloads. OBI manual. It's very big, I think so. So let me check with this PDF. Any PDF, a simple PDF. This PDF, I mean, I think this is a paper. Install file PDF. So the installation has to be good, otherwise it won't respond. So right now it's good. Fine. So now loader is an object. So you can use loader dot load. So it will show the document. So these are all the pre-processing work. So you can check docu. So you just listen here. The entire document is available with me. You can check the entire document is available with me. This is related to Tokyo General Insurance Company Limited. Some related to model. Any motor related document. So the length of the type of the document is list. So you can have the document of 0. I think it's dictionary. So you can check it with dot keys. So you have to good with type of document is it's core document. So the length of document 0, it does not respond with the length. Now the thing is you have to split the document into the chunks for the convenience, and the chunk size to be within the limit of the context window. Context window is LLM part. So these are all somewhat different representations. Okay. So LangChain is one of the important AI framework which is available under the Python AI ecosystem. So once if you are familiar with the LangChain, it will be useful for the model inference at your CLI level. So I am not able to stipulate myself within the short duration. The content is very huge. I already am running out of time, I think so. So thanks for the opportunity.
Participants, we have any queries?
So I have all these articles are available with my Medium. You can follow me on my Medium. So this LoRa and OpenAI, Chat Gemini, Gemma models are explored by myself. I started to write AI articles only. The mathematical intuition, that too I am concentrating only on the mathematical intuitions. So kindly follow me at Medium. So you can scan, or you can simply type Satish Paramasivam, Medium. It will take you to my articles. So almost 7+ articles are published in the context of the artificial intelligence, that to concentrate on mathematical intuitions. So any queries from your side, I'm ready to answer. Sorry for not opening my camera.
Any queries? So I think no queries, sir. Shall we wind up the session?
Hello,
Sure.
hello,
Sir,
hello.
please.
Hello. Good morning. I'm Dr. Brahmpal Singh, sir. Actually, I want to ask that I think most of the discussion related with pollution, environment, something, this kind of thing. So, is there any application or model that can be used to reduce the pollution in this technology that you have described here?
So many researchers are working on different different models in order to maintain the sustainability. But every model is to be associated with the own data. So I'm not able to suggest this is the predefined and higher community accepted model for the sustainable maintenance. That is a fact. It's all under the research. And
Okay, these are under the research.
It's all under the research. Anyway, it's responsible for everyone to be maintain the sustainability and minimize the footprints of the carbon, whatever the model it may be. Right now, as per your the LLM pollution, I don't know. Most of the unicorns are prominent to their work towards the focusing on AI. Okay, as you people are well aware about that. But the thing is, it's responsible for every AI engineers to maintain the minimal carbon footprints of their model. Even if we say, for example, if I'm going to run a very big model with the RAG representation or something fine tuning or in class content, but how long I'm going to take this? What will be the energy consumption I'm going to occupy for betterment of my model? That is very important thing. That's what the transformer into the position. Still, it's under the research. Still, the people, Googlers are the deep work, deep mind. Google Deep Minds are working on the research of maintaining the sustainability. That's
Right.
what I'm not in the position to state that this is the model which consumes minimal carbon effects. So
Right.
as a calculator, it's responsible for every engineers to check with the hardware presentation as well as the computation theory to in order to in order to deploy the model. Prior to that, you have to check with the calculations.
Right, sir. Thank you. Thank you.
Thank you, Professor. Thank you.
So any other questions from the participant side? So thank you, Sadish, for your wonderful session on carbon prints, and you have shown also the demonstration on various models, local AI and all. So thank you so much, sir. So I request Mrs. Asha to conclude the vote of thanks.
On behalf of all participants, we extend a heartfelt gratitude to Mr. Satish Kumar Paramasivam for delivering an insightful session on carbon prints, demonstrations, and hardware requirements to build different models. Your expertise have provided us with deeper understanding of how generative AI can drive innovative solutions to tackle one of the most pressing challenges of our time. Thank you so much, sir, for inspiring us and sharing your valuable knowledge.
Thank you. Thank you.
Thank you, sir.
Thank you.
Thank you.
So I request all the participants to switch on their cameras for a photo session. Okay, thank you. Participants are requested to join by 2:30 for the next session, and you can leave now. Thank you so much.
Thank you. Thank you.